Good morning, friends. So, in the tomorrow's class, we studied about sp3 hybridization, especially what CH4, NH3, and H2. The very important structures for examination. Okay. So, if any structure is going to be asked for 3 months, these are very important from the hybridization. So, in today's class, what I am telling is that is for example for other hybridization, but those are not that much important. Okay. But just remember how to know that and how to study and how to write the hybridization. Understand? So here in the last class we studied what? Structure of CH4 molecule. Next, for sp2 hybridization, today we will discuss. Okay? So the first one is the example I told BCl3 boron trichloride. Okay? Students, remember what is the main thing we need to do? Among these two, we need to consider which one is the central metal atom, which one are the bonded atoms. Here this is the central metal atom, these are the bonded atoms. So to which we are going to write the electronic configuration for central metal atom. So first one is, I know in the last class I already gave you the rules to write the hybridization, rules to find out the hybridization. First one, write in the electronic configuration. Boron atomic number is 5. It is 1s2, 2s2, 2p1. Next, selection of the valence shell. After knowing this, after writing this electronic configuration, write box diagram. That is box diagram for box diagram in ground state. Okay, so this one is, as I told you, we are considering the valence shell electrons. It is 2s, 2p. S orbital is here, p orbital is here. Understand? Second thing is what? The comparison of the number of unpaired electron and the number of bonds. Here the number of electron available for bonding is only one, only single electron. This is already paired up. But here we require 3 bonds. Then what to do? Third point I told you, excite if necessary. Means excitation if necessary. Means here we need to excite the molecule. What is excitation? Jumping of electron from lower energy level to the higher energy level. Of course, from 2s it can easily jump to 2p orbital because they are having small energy difference. So then, box diagram in excited state. Okay, here it is 2s and 2p. S orbital is here, p orbital here. Excitation means the electron of 2s orbital, it jumps to 2p orbital. Okay, so then compare. Here 1, 2, 3 unpaired electrons are there. Here also we require 3 bonds. Then it is satisfied. Okay, so then hybridization. Here 3 bonds we require means we need to consider 3 boxes here. One is yes, P2 hybridization. sp2 hybridization. Next, sp2 hybrid orbitals. Okay, so here these are the hybrid orbitals. This is Box diagram of hybrid orbitals. The next is so here three bonds are there. In the three bonds, three electrons of boron is present. To that, three electrons of chlorine is bonded. So these are sp2 hybrid orbitals of or sp2 hybridization. BCl3. So once we came to know sp2 hybridized, the next thing is what? Structure. Okay, what is the structure of sp2 hybridization? Trigonal planar. Okay, now so boron is here. They have the hybrid orbitals like this in a triangular manner. And at the same time, consider Cl. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. The last electron is what? P orbital. What is the shape of the P orbital? Dumbbell shape. You know, in the yesterday's class that is we wrote one that is 1s1, s orbital is spherical shape. We try to bond the molecule like this. But here the last electron is a p orbital. So here the bonding of p orbital takes place. Here the electrons are present. Okay. So if you consider the structure, okay, this is like a triangular. That is triangular planar. Trigonal planar. The bond angle here is 120 degree. Okay, so here the points we need to write. The first point is sp2 hybridization. Next, structure is trigonal planar. Hybridization is, sorry, not hybridization, bond angle 120 degrees. These are the points to it. Or you may write also 3 bond pairs are there. 3 bond pair, 1 lone pair is there, like that. That's your choice. But these are compulsory ones. So this is about what? The sp2 hybridization of BCl3 molecule. What is the process here? So we need to select the central metal atom, the electronic configuration of the central metal atom, and the box diagram for that, comparison of the unpaired electron and the bonded electron. If they are equal, then no need for excitation. If they are not equal, then we need to excite the electron. Then the box diagram for excitation state. Next, hybridization. Next, box diagram for the hybrid orbital synthesis. Next, box diagram of the BCl3 molecule and structure of the molecule, and those are the points. Okay. So next, another one example. for sp2 hybridization. Okay. Another one example for sp2 hybridization, that is CH2 double bond CH2. CH2 double bond CH2. For this carbon, we need to write the bonding. This carbon. So listen, this carbon is there, is bonded to one hydrogen, another hydrogen, doubly bonded to CH2. 1, 2, 3, 4 are there. Okay, I'll explain the hybridization here. This is not important, remember, because they won't ask the structure BCL during the examination. Then hybridization is they simply ask which type of hybridization is going to be exhibited by these molecules. But the thing you have to remember is what? How to do the hybridization. Remember, I am repeating again and again, only 3 structures are important: CH4, NH3 and H2. Getting? So except that no one structure in this hybridization is important, but they won't ask hybridization, they simply ask write the type of hybridization of this molecule. Only 1 marks question. Okay? So I will take CH2 double bond CH2. So carbon atomic number is 6, configuration is 1s2, 2s2, 2p2. Okay? Now the box diagram. We are considering this shell of course. 2s, 2p. Here 2 electrons, here 1 electron. It is 2s, 2p. So students, for this carbon, 2, 3, 4 bonds are there. Here the availability of electron is how much? Only 2. Means what we need to do? We need to excite the electron. Here the number of electrons available for bonding is only 2. Here the number of our bonds here is for this carbon atom or this carbon atom. Both are same. How much? 4. So we need to excite the molecule. That is, this is 2s orbital. This is 2p. Okay, students, from this, the main thing we need to observe is what? So listen, in this molecule, if I write like this, this is H. This is sigma, this is pi sigma. So 5 sigma bonds are there. Okay. For this carbon only you will consider. For this you won't. Okay. 3 sigma bonds are there. 1 pi bond is there. For this carbon alone I am taking 1, 2, 3 sigma bond, 1 pi bond. And remember, in hybridization, only sigma bonds are considered, but not pi bonds. Are you getting? Only sigma bonds are considered, not pi bonds. So listen, how many sigma bonds are here? 3. Means we need to select 3 boxes here. Why? I'll explain later in the limitation. This is the one of the major limitation of the hybridization. Why it is not considered in pi bond? Why it is only considered in sigma bond? This theory fails to explain that. That's why the next theory is introduced. Understand? So this is different. 2s, this is 2p. Okay. Now the hybridization is what? sp2 hybridization. Okay, listen, no matter whether the unpaired electron is present or not, whether this is empty or not, the main thing we need to consider, how many sigma bonds are there. The number of sigma bonds is equal to number of electrons, then that is correct. Listen, here 1, 2, 3 electrons enough, only 3 sigma bonds are there. We don't need to take this, we don't need to involve this in the hybridization. Remember the concept, okay? Next. So these concepts are helpful to you in the NEET examination rather than this theory. They'll ask simply write a hybridization now. But in NEET, they won't ask. They'll give some structures and roll you to find out the hybridization. Okay? Next. Box diagram of hybridization. So this is the box diagram. This is hybrid orbital. This is separate p orbital. This is the box diagram. These are what? sp2 hybrid orbitals. But this one is alone either px or py or pz orbital. Anything px, py, pz, three orbitals are there. Two are involved in the hybridization. One is left x2, sp2, and this is px or py, pz, whatever you may take. Of course, this is forming what? Pi bond. So px or py you should take. Next, box diagram for CH4 molecule. CH2 double bond CH2 molecule. Remember, so carbon, these are the hybrid orbitals. This is px orbital. This is sp2 hybrid orbitals. So here the bond number of electrons of this one carbon is this carbon. Next, this is electron of hydrogen. This is electron of hydrogen. This one is electron of carbon. Are you getting? Hydrogen, hydrogen, carbon. Like that, the sigma bonds are formed. One is 2 are with the hydrogen, one is with the carbon atom. Hydrogen, hydrogen, carbon. Understood? Now the structure. So listen, one carbon atom is there. sp2 hybridization means planar structure. This one is 1, 2, 3. Similarly, another carbon atom here. I just rotate this molecule like this. Means it is in this direction and simply rotate like this. Okay? Then it is carbon. Okay? This carbon is also having same. This carbon is also having 2 hydrogen, 1 carbon bond. So that is 3 sigma bonds. Same, both are same. So then this is also planar in structure. So I'll simply write the orbitals first, later I'll write the hybridization. So students, here I told you, sp2 hybridization, the one carbon atom is bonded, form bonds, 2 sigma bonds with hydrogen. Means this is with hydrogen, this is with hydrogen. This is also with hydrogen, this is also with hydrogen. So 4 sigma bonds are done. The next one is, they are bonded with, another one is what? With the carbon. Means hybrid orbitals are finished. Listen, 2 electrons, 2 electrons, 2 electrons. If you write the structure, that is trigonal planar only. Each atom atom. So each carbon atom exhibiting what? Triangular planar structure. The next one is, this is what? 1 sigma bond like this. 1 sigma bond. The structure is like this. Now, the next one is what? We left p orbital. It consists of only one electron. The p orbital, that is what we consider the x-axis, x. So that is p orbital of the carbon, both the carbons. Of course, these are p orbitals. Sigma bond is already formed. They overlap sideways. When they overlap sideways, they form another bond called as pi bond. Then this is the structure of ethene molecule. This is how to find out the hybridization. Are you getting? So this is all about what? Structure of ethene. The point is this is sp2 hybridized. Second one is structure is trigonal planar, no doubt, and the bond angle 120. Here we are going to check the bond angle 120. So this is all about the structure of ethene molecule. CH2 double bond CH. This hybridization, another point what we came to know, only the sigma bonds are involved in hybridization, not pi bonds. Remember. So the next one is sp hybridization. For sp hybridization, I will take BeCl2 molecule. Okay. This BeCl2 molecule, okay, and take BH2 first. BH2 molecule. So listen, this is beryllium is there, atomic number is 4, configuration 1s2, 2s2. This is the valence shell. Only one s orbital is there. Of course, in the same shell, p orbital is also there because 2s, 2p are together. But in 2p orbitals, there is no electrons. L shell means it consists of 2s as well as 2p. But the thing here is only in 2s orbital electrons are there. In 2p orbital, there is no electrons. Next, so box diagram in excitation state because here the bonds is 2. Here there is no electrons for bonding. Then what to do? We need to excite the molecule. Means 2s orbital is here, 2p orbital is here. The electrons are present only here. So we need to excite the electron from 2s orbital to 2p orbital. Now the electrons available for bonding is 2. Here the bonds required is also 2. And no need for further excitation. So then what happens? The hybridization. So we require 2 bonds. So we need to select 2 orbitals. So one is the s orbital, another one is the p orbital. That is sp hybridization. Okay. Next we need to write the box diagram. Box diagram for hybrid orbitals. This is sp hybrid orbitals. Next one is box diagram for BH2 molecule. So here, this is the electron of beryllium. So to this electron of hydrogen is bonded. Then they form sp hybrid orbitals. Now the structure. So students, sp hybridization is the structure is linear. So beryllium s and p orbital, of course. Here beryllium is there. The shape of those is like this, partially s character and partially p. This is bonded to one hydrogen. So hydrogen is atomic number 1. That is 1s1. Shape is spherical. So that is spherical in shape. So this is of course linear structure like this. So the bond angle between this is 180 degree. So then the points here, the first one is, it is sp hybridized or sp hybridization. Structure is linear and the bond angle is 180 degree. These are the points of the structure BeH2. Okay? So the next, another one example. CO2 molecule means C double bond CO2 molecule. So students here, the central metal atom here is what? Carbon. So carbon atomic number is 6, configuration is 1s2, 2s2, 2p2. So this is the organization. Here, so box diagram for ground state of the carbon atom is, this is 2s, this is 2p. Here 2 electrons, here also 2 electrons. This is the basic thing. Now the second one is what? Here the 2 unpaired electrons are there, p orbitals. Sorry, in the p orbitals 2 unpaired electrons are there. But here the number of bonds for this carbon including 5 bonds, that is 1, 2, 3, 4. 4 bonds are there. Means we require 4 electrons, 4 unpaired electrons for the respective bonds. Of course the hybridization is different. Then only, listen, this one is pi. This one is sigma. Pi, sigma. How many sigma bonds are there? 2 sigma bonds are there. Only those are involved in hybridization. But even though these are also considered as number of bonds. Here 4 bonds are there. Here only 2 electrons are available. Then we need to excite the molecule. Now, this is 2s orbital. This is 2p orbital. Okay, of course the electron is here. This electron from 2s orbital is jumps to 2p orbital. Now students, 2 are sigma bonds, 2 are pi bonds. So we require only 2 orbitals. So starting from here, and this is the 1 and this one is 2. We require only 2 orbitals. So that's why it is 1 s orbital and 1 p orbital, that is sp hybridization. Now, the box diagram of hybrid orbitals. So listen, this is the box diagram of sp hybrid orbitals, and this one is only p orbital. This must be px and this is p1, because as I told you, only x and y axis p orbitals form what is it? 5 bonds. Z is taken as a main axis. Okay, px and p1. Next one is the box diagram for CO2 molecule. This is the hybrid structure. Px, p1. This is what? sp hybrid. So listen, this is sp, this is px, py. These two are not mixed up. They are separately present like p orbital. They are alone p orbital. Okay, they are not getting mixed up with s orbital. But these two mix up with each other form sp. Okay, now the electron of oxygen is pointed here 1. Okay, they form double bond. Next here, p orbital of electron. So that's why they form 1, 2, 3, 4 bonds. How? I'll explain. Px pi bond, py pi bond. Once we know this is sp hybridization, the structure is linear. Okay? So listen. Initially I will write the structure of carbon here. So carbon, sp hybridization means it has a linear structure, and it is bonded to oxygen. Oxygen means, listen, 1s2, 2s2, 2p4. Here 2p4 means, if we write like this, 2 electrons. So 1 electron of oxygen is involved in sigma bond. 1 is involved in pi bond here. 1 is involved in sigma bond because it is sigma. 1 is involved in pi bond. So sigma bond electron, as it is a p orbital, I will write like this. What is this? Oxygen atom. So students, remember, here I am writing hybrid orbital in this shape, but here I am writing completely p orbital because they are not at all getting mixed up. Only the orbitals of carbon is mixing up with each other to form hybrid orbitals. The bonded atoms are bonded in as it is, means s orbital means spherical, p orbital means double, d orbital means double. Shape of the bonded atom will not change. Shape of the carbon atom only change. So this is number of electrons. Okay, now there is one pi bond in the 2p orbital and two px and py bonds in this side. I take x bond here. X. Okay, so this one is assumed p orbital. Therefore, one pi bond. Listen, initially I will write here oxygen. This is the single bond. C, single bond O. Now here the one bond is formed like this. Next here, of course, this is x orbital. So if we consider p and y orbital, we consider like this. So assume this one is px, this one is y. So this is another orbital of oxygen. Okay, so they will form another pi bond. You are getting? COO, that is sigma sigma bond. So one p orbital of oxygen mix up with one p orbital of the carbon form pi bond. So one p orbital of another oxygen mix up with another p orbital of this carbon form pi bond. This is how CO2 molecule structure takes place. Means the thing is, we are not at all considering the double bond, means the pi bonds in the hybridization. Okay, so this is all about sp hybridization. Next one is PCl. So students, initially I won't mention any hybridization here and directly show you how to take the hybridization. Listen, atomic number of phosphor is 15, configuration 1s2, 2s2, 2p2. Listen, in the hybridization we need to take K, L, M, N shell, not the electronic configuration. K, L, M, N shall be required. Okay, so the next one. 2p6, 3s2, 3p3. 1s2, 2s2, 2p6, 3s2, 3p3. Are you getting? We require what? Shells. After this is K shell, this This is L shell. M shell means 3s, 3p, 3d, 0. Remember that. That is what I am telling. After 3p, of course, 4s will come. But we cannot take 4s because we are considering shells. K shell, L shell, M shell. After 3p, 3d will come in the hybridization. Now, so I write the box diagram. In ground state. Box diagram in ground state. So this one is 3s orbital, 3p orbital, 3d orbital. We need to write the complete empty. So in the s orbital, 2 electrons, p orbital, 1, 2, 3 electrons. Next, compare the unpaired electron and the bonded atoms. Here 1, 2, 3 unpaired electrons are there. Here the bond required is 5. So we need to excite the molecule. Box diagram in excited state. That is same 3s, 3p, 3d. That is 3s, 3p, 3d. So here 2 electrons, here 1, 1, 1. Remember students, if we jump this electron here, again the availability of electron is this much only. So we cannot jump in the 3 orbitals, the electron directly jumps to d orbital. Now, so 1, 2, 3, 4, 5 unpaired electrons are available and the required one is also 5. We can easily do the hybridization now. So now, take hybridization. How to find out? So we require 5 bonds. Start from here. 1 electron, 2, 3, 4, 5 electrons. Okay. So 1 is s orbital, 3 p orbital, 1 d orbital. That is sp3 hybridization. sp3 hybridization. Okay. Next, here hybrid orbitals. Box diagram for hybrid orbitals. So here the 5 orbitals are there. 1, 2, 3, 4, 5. Single electron. What are those? sp3d hybrid orbitals. So the next one is box diagram for PCl5. Consider the hybrid orbitals here. How many? 5, 1, 2, 3, 4, 5. These are singly filled electrons of phosphorus. To that electron of Cl is bonded. This is PCl5 molecules. Okay, so students, we know the hybridization is sp3d. Then the structure is what? Trigonal bipyramidal. Trigonal bipyramidal. So phosphorus is here. sp3 hybridized orbital means the shape is like this. This is trigonal. This is bipyramidal. Okay, so this is what shape of the p orbitals where single electrons are there like this. Now the Cl atom is bonded to the phosphorus hybrid orbitals. So Cl, of course, atomic number 17, 1s2, 2s2, 2p6, 3s2, 3p5. Last electron is in p orbital. The shape of the p orbital is double shape. Here it is. They will when they get bonded, the electrons gets paired up. Now, if you draw the structure, this is in the shape of triangle, triangular bipyramidal. Okay, so here the bond angle is 120 degree. In between these, the bond angle is 90 degree. So this is what the structure of PCl5. You simply write like this: phosphorus, that is Cl, 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 the Cl, Cl. This is the structure of PCl5. You can write Cl here. Okay. Now the points. Hybridization is sp3d. Okay. So orbital, structure is trigonal by pyramidal. The next one is trigonal by pyramidal, and the bond angle is 120 degree and 90. So this is not about structure of phosphorus pentafluoride. So students, for you, homework is write the structure of SF6 molecule or hybridization of SF6. This is for you. Just do it yourself. The sulfur atomic number is 16. Write the configuration, write the box diagram, excite the molecule, then you will get the hybridization. So if you get, you just send this structure of SF6 molecule in the group. If you won't get, I'll explain this in the next class. Okay, thank you.